We are the paradoxical ape. Bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves. Aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. CARTA brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
Good afternoon. I'm Katarina Harvati, and it's a pleasure to be here. And as already mentioned, I'd like to talk today about the modern human expansion out of Africa. So as we already heard today, modern humans first evolved in Africa, with the earliest representatives of our species already found more than 300 or close to 300,000 years ago. However, today we exist everywhere on the globe as an extremely geographically widespread and ecologically tolerant species. And one of the central questions in modern human origins research, aside from pinpointing the time and place of origin, is also how this situation came to exist. So, important questions, for example, include when and how did Homo sapiens disperse out of the African continent? What were the critical factors enabling this dispersal, whether they might be ecological or demographic, social, cultural, technological? What was the possible interaction between early modern humans dispersing out of Africa and archaic hominins already living in Eurasia? And what are the possible impacts that this might have had? And so on. But the very first question that we must answer before addressing anything else is when and how did Homo sapiens disperse out of Africa? And this is what I'd like to talk about today. So what do we know? As we already heard in the previous talk, early modern humans emerge in Africa starting around 300,000 years ago and are found all over the continent. But at this time, during this time frame, we also have archaic hominins, other species that exist in Eurasia. So we have the Neanderthal evolution taking place in Western Eurasia, starting already before 300,000 years ago, and ending with the Neanderthal disappearance around 39,000 years ago. We also have Denisovans that exist in East Asia, possibly also in Southeast Asia, and we have late surviving Homo erectus in Southeast Asia. We also know that the main expansion of Homo sapiens out of Africa started between 70 and 50,000 years before present, with modern humans reaching Australia as early as 50,000 years ago, and then slightly later reaching northern parts of East Asia as well as Europe around 45,000 years ago, finally arriving in the New World around between 20 and 15,000 years before present, and from there really covering the rest of the planet. And this dispersal really sets the stage for the world as we know it today. However, the story is not so simple. We have known for many years that Homo sapiens dispersed out of Africa already in an earlier migration wave. We have evidence from the Near East, from the sites of Skul and Kapse, that shows early Homo sapiens arriving there between 130 and 100,000 years before present. Recent evidence from a nearby Mislia cave site has put this early dispersal of Homo sapiens into the Levant at an even earlier date, close to 180,000 years before present. What's more, in later periods, so after 100,000, there are Neanderthals found in the same region, and no longer early modern humans, suggesting that these early Homo sapiens did not persist in the long term in this region, but they were rather perhaps replaced by Neanderthals here, until the later main out of Africa dispersal at 60,000 years before present. So what do we know about this early Homo sapiens dispersal? We know that it reached the Levant, possibly as early as 180,000 years before present. We generally consider it a failed dispersal, meaning that the populations of early modern humans did not actually stay, did not persist, did not survive in the long term, but were probably replaced by Neanderthals. This kind of dispersal might have been enabled by environmental shifts linked to the glacial cycle, such as the one that we heard about earlier from Jean-Jacques Hublin. And we also have paleogenetic evidence that suggests an ancient interbreeding event took place between Neanderthals and early modern human ancestors even before 200,000 years before present. So all of this basically means that we have been considering the Levant as a possible contact zone between Neanderthals and modern humans, where they might have encountered one another and possibly exchanged genes at this early time, but also later on in the main out of Africa event. So this brings me to the site of Apidima and our recent work on the fossil human skulls from this site. Apidima is situated in the Mani Peninsula in southern Greece, at the southernmost point of mainland Greece that is shown here on the map inside the red circle. The site is a cave complex that was investigated in the late 1970s and 1980s by a team from the University of Athens Medical School. And it is during this work that 2 human fossil crania were discovered, encased in a block of rock, a breccia rock, found in the ceiling of one of the caves, Cave A, that is shown here. Now here you see the original photograph from the late 70s showing the rock in the ceiling, you see it here in red, where the human crania are encased and as it is about to be removed. And as you can see, this block of breccia is actually rather small, and the 2 specimens were found very close to each other. The site itself could not be dated properly at the time of the discovery, but it was estimated that the skull breccia, this piece of rock containing the human remains, was between 150 to 400,000 years old. And a few years ago, a small fragment from one of the skulls, Apidima II, was dated to 150,000 years before present, approximately, confirming this hypothesis. So despite their obvious importance, these fossil crania themselves remained unstudied and unpublished, and very little was known about them except preliminary assessments. Previous observations were made exclusively on one of these specimens, Apidima II, which is the one that is better preserved, so it actually has a face and most of the skull. And all these observations were based on a handful of published measurements and a couple of published photographs, and it had been noticed that the specimen has Neanderthal or pre-Neanderthal affinities, but the specimen also suffered obviously from distortion and damage after death. As you can see here, is rather crushed and distorted, so its interpretation was actually quite complicated. Now the situation was even worse for the other human specimen, Apidima I, which is much less preserved, so there's a lot more of it missing, but it's not distorted. It was cleaned much later, so it was left inside the rock until approximately 2003, when it was cleaned and removed, and it was never described or published. No published photographs of it existed before. So approximately 2 years ago, I was approached by colleagues from the University of Athens Medical School who asked me to lead a new investigation and reanalysis of this important fossil material. So in this new analysis, what we did was we applied virtual anthropology methods to reconstruct the Apidima specimens virtually, and then we conducted exhaustive comparative analysis of their anatomy and their anatomical shape using the methods also mentioned previously, 3-dimensional geometric morphometrics, so that we could statistically analyze their shape and elucidate their affinities. Now, because the 2 crania preserve mostly different parts of the cranium, we had to mostly analyze them separately. But we conducted also a combined analysis, and I'm going to show you the results of this. And finally, we also applied new uranium series dating in order to shed light on the chronology and actually test the idea that the two specimens came from the same time period. What I didn't mention before is because they were found so close together, they were generally assumed that they lived roughly at the same time and they belonged to the same species and possibly even the same group. So we conducted dating analysis of the specimens themselves also to test this idea, was it actually true? In this slide you see the process of reconstruction or virtual reconstruction of the specimen Apidima 2. And you see on the, well, on your left side, the 3D model derived from a CT scan. And in the middle, what you see is the segmentation, the virtual dissection of every bone fragment, so that we could then, in fact, isolate each bone fragment, clean the sediments from inside the cracks, and move the bone fragments back to the original correct anatomical position. And the final result you see on the other side, which is one of the reconstructions that we conducted. Because this kind of reconstruction it could involve some error associated to different observers, we actually produced 4 different reconstructions by 2 different observers following 2 different criteria so that we could somehow correct for any observer error. The result was actually 4 quite similar reconstructions, and we use all of these reconstructions as well as their mean in our further analysis as individual specimens. Things were quite a lot simpler for Apidima 1. I mentioned to you before that it's not so well preserved, but it's not distorted. So the reconstruction of this specimen basically consisted of mirror imaging the better preserved side so as to have a more complete specimen to work with. So let's look at the results. Now we'll start with Apidima 2 because this is a specimen that is better known and have been studied somehow before. Its overall dimensions and cranial bone thickness indicate that it is an adult, and its linear measurements align it with Neanderthals, as it was previously stated in the literature. It has a whole suite of unique Neanderthal features present, including the morphology of its brow ridge and the morphology of the face, as well as details of its cranial anatomy. And what about if we actually statistically look at its shape? And you saw these sorts of plots before in Jean-Jacques' presentation. They are principal components analysis of 3D measurements. The one on the left is the facial, based on measurements from the face, and the other one is based on 3D measurements from the rest of the skull. And what you see here, again, as you saw before, is modern humans shown in blue, and Neanderthals all the way out here shown in red. And these yellow specimens are pre-Neanderthal, so European Middle Pleistocene, and the pink ones are early African, possibly Homo Sapiens ancestors. So in both of these analyses, what we see is that Apidima 2 clusters with Neanderthals or between Neanderthals and pre-Neanderthals, exactly like it had been proposed before. We conducted also a classification analysis, and here you don't have to look at these numbers, but all you need to know is that Apidima 2 was classified in almost all cases as a Neanderthal with very high probability, and only in one case as a pre-Neanderthal, a Neanderthal ancestor. So, all in all, our results on this specimen agree with previous assessments of this skull. Now, turning to Apidima 1, now things are a little bit different. Again, the overall dimensions and cranial bone thickness indicate that it's an adult, and the part of the anatomy that it preserves, the back of the skull, actually should show quite a lot of unique Neanderthal features that are normally present in Neanderthals, but also pre-Neanderthals in this anatomical region. Nevertheless, Apidima 1 shows none of these features. Instead, it shows a combination of ancestral and uniquely modern human features, and most strikingly, the feature that was already mentioned before, the rounded aspect of the back of the skull, which is something that we normally associate only with modern humans. Do these observations actually hold up when we analyze the shape in 3 dimensions? And here again, you see 2 different analyses, one based on 3D measurements reflecting overall neurocranial shape, and one specifically looking at the shape of the midline profile of the posterior part of the cranium. And again, you see modern humans in blue, Neanderthals in red, and earlier Middle Pleistocene Europeans here in yellow, and Middle Pleistocene Africans here in pink. And in both situations, again, you have in both analyses Apithema 1 plotting with the modern humans. Classification results are even more striking. In the neurocranial analysis, it's 100% posterior probability that Apithema 1 is a Homo sapiens, and in the mid-sagittal profile analysis, more than 90% posterior probability. We also conducted a combined shape analysis. This is the two specimens do not preserve a lot of the same morphology, but we wanted to see what they look like if we analyze them together, and we produced a reduced data set of only the measurements which we could measure on both of these specimens. And again, now the results are very similar to what we had before. Apithema 2 plotting within Neanderthals, Apithema 1 just outside the modern human polygon. Classification, very similar to what we had before. Apithema 2, more than 90% probability of being a Neanderthal, and Apithema 1, more than 90% probability of being a modern human. So turning now to the new dates, and this was another surprise waiting for us. As I mentioned to you before, we applied the laser ablation uranium-thorium dating method, which is an appropriate method for this time period, and we applied it directly on fragments from Apithema 1 as well as Apithema 2, also on fragments of unidentifiable bone from the same block of breccia, as well as on the matrix, the sediment itself. So these are the results. The sediments, the matrix, date to approximately 150,000 years before present. What this means is that this is the time when the dirt, the ground around the specimens, solidified into rock. So you cannot really add anything to this block after this point in time. The unidentified bone fragments produce two clusters of dates, one around 160,000 years and one more than 200,000 years before present. And the two human specimens fell roughly in these two clusters. Apithema 2 dated to 170,000 years before present. Apithema 1 dated to approximately 210,000 years ago. Now, this means that Apithema 1 is older than Apithema 2. So the early Homo sapiens is older than the Neanderthal in this site. And it also, of course, indicates that the final resting place where these specimens were recovered was not the original place of deposition. How do we explain this? Again, I remind you where the specimens were found, in a kind of crack in the ceiling, crack between rocks filled with this breccia bone, with this breccia rock. Now, the uranium uptake signatures and the different ages suggest that these two human fossils actually come from completely different parts of the cave, where they must have later been eroded and fell into a kind of fissure filling where they got thoroughly mixed in with the sediments solidifying around them at 150,000 years. So in conclusion, Apithema 2 belongs to the Neanderthal lineage. It fits every expectation of Neanderthal evolution as we know it from the rest of Europe. Apithema 1 does not. Instead, it possesses a combination of ancestral and modern human features, plots with and is classified as Homo sapiens, is always closest in overall shape to modern human individuals. So there must have been two populations living in what is now southern Greece in the Middle Pleistocene, an early Homo sapiens group, approximately at 210,000 years before present, followed by a Neanderthal population at least 170,000 years ago. So in fact, the situation as it's shown by the Apithema fossils seems to be rather similar to what we have in the Levant, where early modern humans appear to have dispersed early. And in my view, actually, Apithema 1 probably represents the same dispersal wave as the Mislia specimen in Israel. Furthermore, in both regions, early modern humans seems to not have persisted in the long term, with Neanderthal populations appearing and sort of replacing modern humans in both of these regions, as is shown in Greece by the Epidema 2 fossil, but also by other sites exactly in the neighborhood, such as Kalamakia and Lakonis, that have also produced Neanderthal remains. So what are the implications now for modern human origins? This work shows that the early dispersal of Homo sapiens out of Africa occurred earlier and reached much further than previously thought, reaching Europe by 150,000 years earlier than previously suspected. This fits well with evidence from Israel, where we have Homo sapiens presence by 180,000 years ago. It also fits with genetic evidence that has suggested an ancient interbreeding event between Neanderthals and modern humans before 200,000 years. So this work actually creates quite a lot of new questions. One of the most important ones, perhaps, is, was this a failed dispersal? And if so, why? Why did modern humans not persist? Why did they not survive in these regions like they did later on with a later dispersal out of Africa? But in my view, of course, one of the most important implications is that perhaps we should consider the broader Eastern Mediterranean region as a possible contact zone between Neanderthals and modern humans. And with this, I would like to thank all my collaborators and team members, as well as all the funding agencies, and of course you for your attention.